Rules of logs, condensing and expanding. Made easy. Let's go over the product rule, quotient rule, and power rule first. The product rule. What the product rule states is that when you have two logs and they are being added to each other, you can combine them by multiplying the numbers. Bases need to be the same, and the base cannot equal 1. Let's look at a brief example. We have log base 4 of 3 plus log base 4 of a. Applying the product rule, we can condense the log. The condensed log becomes log base 4 of 3a. All we do is multiply the 3 and the a together. The quotient rule. What the quotient rule states is that when you have two logs and one is being subtracted by the other, you can combine them by dividing the numbers. The bases need to be the same, and the base cannot equal 1. Let's look at a brief example. We have log base 4 of 3 minus log base 4 of a. Applying the quotient rule, we can condense the log. The condensed log becomes log base 4 of 3 divided by a. The power rule. What the power rule states is that when you have a log and the number is being raised by an exponent, you can multiply the exponent to the log. The base cannot equal 1. Let's look at a brief example. We have log base 4 of a raised to the third power. Applying the power rule, we can move the exponent in front of the log. The log now becomes 3 times log base 4 of a. Example, condense the logs. We are given 10 log base 5 of x minus 3 log base 5 of y minus 6 log base 5 of z. The bases here are equal. The base is also not equal to 1. Since that is the case, we can apply the log rules. Step 1. We're going to use the power rule. The power rule states that if you have a number multiplied by the log, the number being multiplied will now be the exponent of the number within the log. Completing the power rule, we get log base 5 of x raised to the 10th power minus log base 5 of y raised to the 3rd power minus log base 5 of z raised to the 6th power. Now we can complete the product and quotient rules simultaneously. The product rule states that if the log is positive, the number will be in the numerator, and if the log is negative, the number will be in the denominator. We can see that log base 5 of x to the 10th power is positive, and log base 5 of y to the 3rd power, and log base 5 of z to the 6th power is negative. Therefore, our x term will be in the numerator, and our y and z terms will be in the denominator. Completing the product rule and quotient rule, we get log base 5 of x to the 10th divided by y to the 3rd and z to the 6th. This is our final answer. Example, expand the log. We are given log base 3 of a to the 5th times c squared over b raised to the 7th. First, we check the base and make sure it is not equal to 1. In this case, the base is not equal to 1, therefore we can continue. Let's begin by expanding using the product and quotient rules. Whenever the numbers are in the numerator, when we expand, the logs are positive. This means they will be added to each other. Whenever the number is in the denominator, the log is negative, meaning it'll be subtracted from the rest of the logs. Using the product and quotient rules, we get log base 3 of a to the 5th plus log base 3 of c squared minus log base 3 of b to the 7th. Now we can use the power rule. The power rule states that when our number has an exponent, we can move the exponent in front of the log. Using the power rule, we get 5 log base 3 of a plus 2 log base 3 of c minus 7 log base 3 of b. This is our final answer.